Besides eliminating race fluting, ceramic balls run considerably cooler than steel balls due to a reduction in micro-weld adhesion. This can occur with a marginal lubrication due to the welding of peaks of steel contacting each other under extremely high pressures. Champion Bearing offers this type of construction with a steel or vibration-absorbing Teflon composite retainer, trademarked Barroweye. This article, A Shocking Approach to Lubrication, appeared in the Machine Design magazine February 24th of the year 2000. Lubrication is another issue that requires frequent attention in ball bearings. Oil keeps many machine components running smoothly, but in some applications, such as semiconductor manufacturing, oil becomes a contamination. And in applications where low friction is critical and oil actually bogs down moving parts so much that designers seek components that can run without it. Eliminating oil may seem ludicrous to some designers, but engineers at Champion Bearing in Palm Springs, California have found ways to use solid film lubricants and decrease friction to less than that of oil lubricated systems. The underlying principle of lubrication is that oil maintains a boundary between two moving parts. On a microscopic level, however, part surface resembles hills and valleys. If these surfaces come in contact and slide across each other, they generate friction and heat. If enough heat builds up, the low surface briefly melt together. This phenomenon is called micro-weld adhesion. As the components continue to move, the micro-welds break apart and remove material from the component surfaces. To resolve this problem, without using oil or grease, Richard Kay, CEO of Champion Bearing, uses a process called ion deposition to electrically adhere surface lubricant particles to the part surfaces. When this process is used on ball bearings, for instance, assembled bearings are mounted and rotated in a vacuum chamber filled with argon gas. The material to be ion doped, such as tungsten disulfide, is heated electrically to its boiling point. Argon ions, accelerated by electrical voltage, collide with the atoms of evaporated tungsten disulfide. This imparts kinetic energy to the tungsten disulfide in the direction of the bearing and lodges the material into the microscopic valleys of the bearing surface. We don't change the dimensions of the bearing very much with what we do, reports Mr. Kay. We lay down about 2,000 angstroms of tungsten disulfide or molybdenum disulfide. Although solid film lubricants have been around since the 1960s, Champion has developed hybrid bearings using raceways coated with ion-doped and ceramic balls and Teflon-based retainer material called Barroweye. As a result of this development and other emerging technologies, this requires hybrid bearings. The company has seen a recent surge in its product.